Good evening, class. Welcome to Chapter 3.4, Solving Equations with Variables on Both Sides. So it's not going to change too much from what we've learned in Chapter 3.1 to 3.4. Just adding a little different twist to it. So here are the rules. You're going to simplify each side of the equation first, combine like terms. We're already doing that. Okay, you've already worked on that on the worksheet, and you've worked on that in 3.3. So, step 1. The second step is collect the variable terms on the side with the greater variable coefficient. Okay, so you'll see this in the example, but remember what coefficient means. Coefficient is the term, the number that occurs before that variable. Okay, so that is the coefficient. Okay, so when we talk about with the greater variable coefficient, you'll understand that in a second, but we're really looking at the numbers that are in front of that x. Remember, there's always that multiplication sign there too. And then third, you want to isolate the variable. Okay, so very similar steps to what we've solved before, just adding one more in there and you'll see it. So here's an example. We have 7x plus 19 equals negative 2x plus 55. So first step was to simplify each side of the equation. So if we look at 7x plus 19, we can't combine those. Those are not like terms. Negative 2x plus 55, not like terms, can't combine those. Okay, so we can go step 2 right out the bat, is we want to combine the variables on one side of the equal sign. We want to make sure that we leave, in the end, we will have a positive number in front of our variable. That's always a goal. So we can look here and look at the coefficients. We have 7 and negative 2. So since 7 is greater, we want to bring the negative 2 over, and we have to add it because it's negative. So let me erase that little sign underneath the 7 now, if I can. Nope, I'll just leave it. But this is 7x plus 2x now, which is 9x plus 19 equals 55. And again, I brought the 2 over because the 7 was larger than the negative 2. Remember, the coefficient in front of the x is what I'm looking at. And I want to bring over the less one to the greater one. And we do that because we're hoping to always have a positive coefficient. It may sometimes end up being a negative, but we prefer that it's a positive coefficient. So here is an equation we've seen before. Now we're trying to isolate the x. Subtract 19 from each side. 9x equals 36. Divide by 9, x equals 4. So now, the thing about checking our work is in the end we have two things. We have negative 2x plus 55, and we have 7x plus 19. And now it's pretty neat is because we have this equal sign. We need it to be balanced now. Remember that balance beam kinda? We want to make sure that we're balanced on each side here. So when we plug in 4, this is negative 2 times 4 plus 55. So that's negative 8 plus 55. And I know since 55 is positive and the 8 is negative, I'm going to subtract these. So that will give me a 47. So I plug in 4 on this side. 7 times 4 is 28. 28 plus 19 is 47. So 47 equals 47. 4 I know is my solution to this problem. Okay, so I know that was our first problem, so just relax. We'll have another example here. So we have 80 minus 9y equals 6y. So I look on each side of the equal sign. I can't combine like terms at all on each side of the equal sign. So now I'm going to bring the variable over. And this is a negative 9 coefficient and a positive 6. So I want to bring the 9 over. 80 equals 15y. And now I want to isolate the y, so I divide by 15. Y equals which equals 8. Excuse me. So if I plug 8 in, remember we're trying to get this balanced again. Plug the 8 in for the y, so we know that 80 minus 72 equals 48. And 80 minus 72 is 8. 8 equals 48. Uh-oh. Did something wrong. That does not equal each other. So I got to go back. I'll leave this there so we can kind of look at that. But I'll erase right here. I know that 15 times 8 120. So I was way off. So 6 times 15 90. So that tells me that 15 will not go into 80. Okay. So if I multiplied it by 5, I wouldn't be given that as well. So what I have to do here is when I'm looking at this, sorry about that, I'm going to reduce it. Okay. So if I reduce this, okay, if I take a 5 out of each of these, so 5 goes into 80 16 times. So my answer is 16 over 3. Okay? Or you could say, I'm sorry about that, 16 over 3. 5 and 1/3. Okay, same thing. Now checking this will be a little bit difficult. It's going to be a little bit different. But you could do it. So I'll move it up here and run out of room. Actually, I'll erase this. This is the part that I... So if I have 80 minus 9 times 16 times 3 equals 6 times 16 over 3. Remember this is 9 over 1, so I can kind of cross reduce here. 3 times 16 is 48 equals, cross reduce is 2 equals 32. So 80 minus 48 is 32. 32 equals 32. Checks out. Okay, so go through your steps again. If you get it wrong, okay, you should be able to notice that through checking your work. Kind of like I did. Okay, more examples here. 4 parentheses 1 minus x, end parentheses, plus 3x equals negative 2 parentheses x plus 1. So similar to today, we're going to distribute first and then combine like terms if we can. 4 minus 4x plus 3x equals negative 2x minus 2. Now if I can combine like terms, I need to do that. So 4 minus 1x equals negative 2x minus 2. Now we've got to focus on what we've been working on. We're going to, now we got to kind of look at this now. There's a negative 1x here and a negative 2x. Well, the largest coefficient is negative 1, but if I add 2x over, I'm going to be left with a positive 1x, which I want to have. Subtract 4. 1x equals negative 6. Okay, I brought the 2x over so that I can have a positive coefficient there. Okay, so it's very important that you're left with a positive coefficient.